Okay, so this video is over the Pythagorean theorem and distance formula. Our essential question is, how do I calculate distance? And I'm going to show you two different ways. The first way has to do with the Pythagorean theorem. This should not be anything brand new to you. It should be a review. You've already had even a homework assignment over it. And the important thing to note is that the Pythagorean theorem only applies to right triangles. So we can only use the Pythagorean theorem when we are using a right triangle. So remember, we have a right triangle. That means that we have a 90 degree angle in there. So the Pythagorean theorem is, maybe you'll remember it by the formula. It states that a squared plus b squared equals c squared. Where on the triangle, the a and the b is actually going to be the sides of the triangle. And then the c is what we call the hypotenuse. The c is always opposite the 90 degrees. So a and b are the sides. And then the c is called the hypotenuse. And it's important to note that the hypotenuse is always across from the right angle. So always across from the right angle. So let's take a look at the first problem that we have. It says, find the distance of the line segment using the Pythagorean theorem. So we're not calculating slope now. We're doing stuff a little bit different. We are going to be calculating how long is this. So without, not with a ruler, and we can't just guess. We can't just say, okay, that's 1 box, 2 box, 3, 4, 5, 6, 7, 8, 9, 10, 11. We can't just guess that. So we're going to actually calculate what is the approximate distance between that. So what we're going to do first is we're going to actually make a right triangle. So kind of what we did with slope. And we're going to box this in. Because the sides we can actually figure out. I know that this distance of the right triangle is 1, 2, 3, 4, 5, 6, 7. So there's 7 units right there. And then on the bottom we have 1, 2, 3, 4, 5, 6. So one side length is 6, the other side length is 7. And then this is the one that we're trying to figure out. We're trying to figure out what is this special distance right here, because this one I cannot count the boxes since it is diagonal. So we're going to use our a squared plus b squared equals c squared. And so a is going to be one of the sides and b is going to be the other side. It really doesn't matter which one is going to be which. We're going to add them together no matter what. So if I use a is 7, that means that I'm going to insert 7 for a. I do that with parentheses. I insert with parentheses. 7 squared plus parentheses 6 squared equals my hypotenuse squared. 7 times 7 is 49. 6 times 6 is 36. And that still equals c squared. So go ahead and add these together. We get 85. 85 equals c squared. And now we want to get rid of the squared. So it's the opposite of squaring something. Remember, that's to take the square root. So I'm going to square root that. What you do to one side, you do the other. I'm going to square root that as well. And so now I'm going to take my calculator, and in my calculator, I'm going to type in the square root button, and it's right actually in blue above x squared. So here's x squared, and right in the middle is the square root. So in order to type that in, I have to hit the blue button, which is second, and then I'm going to hit that, and now I have my square root symbol, type in 85 and hit enter. So I'm going to have to round this here, and you're most likely going to get a messy number anyways. So I have 9 point, let's round it to 2 decimal places, otherwise known as the hundredths. So we have the tenths and the hundredths. I look to the right, that is a 9. 9 tells me that this number needs to go up, so it's 9.22, and that's approximately, so I'm going to change my equal sign because I had to round. It's approximately the value of C. So, and that makes sense why I couldn't count this right here. I can't really count 9.22 boxes, but that is the exact distance right there. So what I want you to do is I want you to pause this video right now, and I want you to try the second one on your page. So pause and try the video. Okay, so you should have, we're looking for an answer of about 10.30 or 10.3 because you had to round on that. So the first thing I did was I made my box, my right triangle. I counted 5 boxes on the left, 9 boxes on the bottom. So I plugged that in for A and B. 5 squared is 25. 9 squared is 81. And that still equals C squared. 81 and 25 is 106 equals C squared. In order to get rid of the square, I square root. And then the square root of 106 is 10.30. So to see that on the calculator, square root 106, and this is what I got, 10 point, and then I looked at this 9, I looked to the right, that was a 5, so 5 tells me I have to round up. Now since this is a 9, I have to go up again, and that's going to turn this into a 3, so 10.3 or 10.30. Okay, so this is the Pythagorean theorem. Now we're going to calculate the distance using the second method, which is the distance formula. So, important to note, the distance formula was actually created from the Pythagorean theorem, so this is actually going to look really familiar, and it's going to be very similar to the actual Pythagorean theorem. The distance formula, D equals, and we're going to have a big square root. And what we're calculating here is the change in x, and we're going to square that, plus the change in y, and square that. So that's one way of looking at the distance formula. Or you could use a different one that's a little bit more specific. It's D equals, and what is the distance, the change in x? That's going to be your change in x. Think about also how we calculated slope, the change in x. That's x2 minus x1, parentheses squared. And change in y, that's the same thing as looking at your two y values and finding the difference. y2 minus y1 and squaring that. So these two formulas, the top one is just a shorthand version of the bottom one, are both going to work. And so the nice thing about this is this doesn't only apply to right triangles. This works for any distance. Even if you're not given a graph, if you're just given the coordinates, this is going to work. So the distance formula is sometimes a little bit more helpful. Even though you think it might look a little bit more complicated, it's actually going to be very similar. So let's actually apply this. Let's find the distance formula of the line segment. Let's find the distance of the line segment using the distance formula. So the first thing that you need to do is you're going to label your endpoints. So identify your endpoint here, and identify your endpoint there. So identify endpoints. That's your first step. So this, from the point of origin, I'm going left 5, up 5. So this coordinate is -5, comma 5, x and y. And then to get to this one, I'm going forwards 1, which is a positive 1, down 2, -2. And so the next thing I'm going to do, so then after I identify my endpoints, I'm going to plug them into the formula. So now just going to plug it into this formula right here. x2 minus x1, y2 minus y1. So we have D equals, go ahead and draw a huge square root symbol. And I'm going to do x2. So x2 right here. And I have for x2, it doesn't matter which point is which, so just pick one. So I'm going to do, I'll call this the second point. So there's x2. So I have 1 minus, and then my x1 is a -5. And so we're going to parentheses around that, and we'll square it in just a minute. And then to do the next one, I'm going to use my y2. So that's a -2. And I'm going to subtract my, let's see, my y1, there we go, which is 5. And then I'm going to close the parentheses and square that. So let's simplify. 1 minus a -5, that's 6. So I have 6 squared. -2 minus 5 is now -7. There we go. So we have a -7 squared. So 6 squared is 36. -7 squared. Make sure that when you plug this in, you use parentheses. So you should have parentheses, -7, close parentheses, and then on these calculators, you're looking for this button right here. This is going to give you your exponent. So it basically moves the cursor up right there for you to type in the 2 and hit enter. So you get 49. So -7 times -7, that's 49. Now add those two together, 36 plus 49, we get 85. And then the square root of 85, we're going to have to round this one. The square root of 85, that's going to be 9.2 or 9.22. Okay, so pause the video real quick. Pause the video real quick and try this second one on your own. Try to see if you can get the right answer. Do that now. Okay, so you should have ended up with 10.3 or 10.30. So I looked at my change in x. So I had a -4 and a 5. What's the distance between -4 and 5? So think about it. If here's a number line, I have -4 over here, and I have 5 over here. I know 0 is a little bit in the middle. So in order to get from one to the other, that's 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's a distance of 9 between those. So that's where I get this 9 squared. And then for my change in y's, I've got -3 and I have a +2. So what's the distance between a -3 and a +2? So we'll change this. We'll make that -3, and that's 2. So in order to go from -3 to 2, I have to go 1, 2, 3, 4, 5. So there's going to be a 5 right there. Square both of those, add them together, square root, I get 10.3. Okay, so go ahead, I want you to summarize these notes. What were these notes about? Be specific, and then go ahead and start on any practice pages or practice assignments you might have.